If Babe Ruth can hit this ball, he will set a new record of 714 home runs. The ball is coming. He hit the ball. It's a new record. This is a very critic game. Hank Aaron has a record of 714 home runs, and if he can hit this ball, he will set a new record of 715 home runs. It's a new record! This is Carl Pomerantz. He is a mathematician at the University of Georgia. Wow, this new record is very interesting. These numbers, 714 and 715. I think I can find something interesting with these numbers. Let me have a study. After all my studying, I think I found something interesting about these numbers. Carl Pomerantz first used prime factorization for the numbers 7, 14 and 715. Here is a quick reminder of how to do prime factorization. What is prime factorization? Prime factorization is finding which prime numbers are multiplied together to make the original number. As an example, let's find the prime factors of the number 12. The smallest prime number that the number 12 can be divided by is 2. When 12 is divided by 2, we get 6. The smallest prime number that 6 can be divided by is again 2. And when divided, we get 3. And the smallest prime number that 3 can be divided by is 3. And then we get 1. So, these numbers on the right side are the prime factors of the number 12. When 2, 2 and 3 are multiplied, you get 12. 714 with prime factorization is 2 times 3 times 7 times 17, and 715 with prime factorization is 5 times 11 times 13. What Carl Pomerantz found was that when 714 and 715 are multiplied and the product is factorized into primes, we get every single prime number up to 17. Wow, this property that I found is very special. The product of two consecutive numbers is equal to the product of all of the prime numbers up to some point. This property also works for smaller numbers. For example, 5 and 6 are two consecutive numbers. When their product is prime factorized, you get every single prime number up to some point. Another example would be 14 and 15. Even though it's not yet known for sure if this property works for larger numbers than 714 and 715, it most probably does not. I will now go to school and ask my colleagues if they could find anything interesting with these numbers. Hey William. Hey Carl. How are you? Fine, thank you. You? Fine, thanks. I have a question for you. Can you find anything interesting with the numbers 714 and 715? Let me think about this for a second. Have you tried prime factorization? Yes, I did. but you found the same thing as I did. I was wondering if I could find something else with these numbers. Well, let me ask my class. Maybe one of my students can find something interesting. Okay, thanks. Good morning, students. Today, I would like to start my class with a question. Can any of you guys find anything interesting with the numbers that I've written on the board? I'll give you some time to think. Mr. Williams? Yes? I think I found something interesting. Can you come up to the board and show us, please? Yeah, sure. Here comes another property. What if all of the times signs are changed into plus signs? We can see that these numbers all add up to the same number. 2 plus 3 plus 7 plus 17 adds up to 29, and 5 plus 11 plus 13 adds up to 29 as well. Wow, I'm really impressed. You found something really important. Thank you. Thanks, Mr. William. Hey, Carl, you won't believe what one of my students found. What have they found? Well, let me show you. Oh, wow! That is very smart. Now that we know this property, we should start a study on these numbers. And I know what to name these numbers. We'll call them Ruth-Aaron pairs. This was the story of how Ruth-Aaron pairs were found. Here are some other examples. Here is a definition for Ruth-Aaron numbers. Ruth-Aaron numbers are a pair of consecutive integers such that the sum of the prime factors of n and n plus 1 are equal. And yes, surprisingly, Ruth-Aaron triplets exist as well. Here is an example for a Ruth-Aaron triplet. Again, all the prime factors add up to the same number.